We have a list of 15 numbers here, and what I want to do is think about the outliers. And to help us with that, let's actually visualize the distribution of actual numbers. So let us do that. So here on a number line, I have all the numbers from 1 to 19. And let's see, we have two ones. So I could say that's 1, 1, and then two ones. We have 1, 6, so let's put that 6 there. We have got 13, or we have two 13s, so we're going to go up here, 1 13 and two 13s. Let's see, we have three 14s, so 14, 14, and 14. We have a couple of 15s, 15, 15, so 15, 15. We have 1 16, so that's our 16 there. We have three 18s, 1, 2, 3. So 1, 2, and then 3. And then we have a 19. And then we have a 19. So when you look visually at the distribution of numbers, it looks like the meat of the distribution, so to speak, is in this area right over here. And so some people might say, okay, we have three outliers, these two 1s and the 6. Some people might say, well, the 6 is kind of close enough. Maybe only these two 1s are outliers. And those would actually be both reasonable things to say. Now, to get on the same page, statisticians will use a rule sometimes where they say, well, anything that is more than 1.5 times the interquartile range from below Q1 or above Q3, well, those are going to be outliers. Well, what am I talking about? Well, let's figure out the median, Q1 and Q3 here. Then we can figure out the interquartile range, and then we can figure out by that definition what is going to be an outlier. And if that all made sense to you so far, I encourage you to pause this video and try to work through it on your own, or I'll do it for you right now. All right, so what's the median here? Well, the median is the middle number. We have 15 numbers, so the middle number is going to be whatever number has 7 on either side, so that's going to be the 8th number. 1, 2, 3, 4, 5, 6, 7. Is that right? Yep, 6, 7. So that's the median. And then you have 1, 2, 3, 4, 5, 6, 7 numbers on the right side too. So that is the median, sometimes called Q2. That is our median. Now, what is Q1? Well, Q1 is going to be the middle of this first group. This first group has 7 numbers in it. And so the middle is going to be the 4th number. It has 3 and 3. 3 to the left, 3 to the right. So that is Q1. And then Q3 is going to be the middle of this upper group. Well, that also has 7 numbers in it. So the middle is going to be right over there. It has 3 on either side. So that is Q3. Now, what is the interquartile range going to be? Interquartile range is going to be equal to Q3 minus Q1. The difference between 18 and 13. Between 18 and 13, well, that is going to be 18 minus 13, which is equal to 5. Now, to figure out outliers, well, outliers are going to be anything that is below. So outliers are going to be less than our Q1 minus 1.5 times our interquartile range. And this, once again, this isn't some rule of the universe. This is something that statisticians have kind of said, well, if we want to have a better definition for outliers, let's just agree that it's something that's more than 1.5 times the interquartile range below Q1, or an outlier could be greater than Q3 plus 1.5 times the interquartile range. Interquartile range. And once again, this is somewhat, people just decided it felt right. One could argue it should be 1.6, or one could argue it should be 1 or 2 or whatever, but this is what people have tended to agree on. So let's think about what these numbers are. Q1, we already know, so this is going to be 13 minus 1.5 times our interquartile range. Our interquartile range here is 5. So it's 1.5 times 5, which is 7.5. So this is 7.5. 13 minus 7.5 is what? 13 minus 7 is 6, and then you subtract another 0.5 is 5.5. So we have outliers would be less than 5.5, or Q3 is 18. This is once again 7.5. 18 plus 7.5 is 25.5, or outliers greater than 25.5. So based on this, we have a kind of a numerical definition for what's an outlier. We're not just subjectively saying, oh, this feels right or that feels right. And based on this, we only have two outliers, that only these two ones are less than 5.5. Only these two ones are less than 5.5. This is the cutoff right over here. So this dot just happened to make it. And we don't have any outliers on the high side. Now, another thing to think about is drawing box and whiskers plots based on Q1, our median, our range, all the range of numbers. And you could do it either taking in consideration your outliers or not taking into consideration your outliers. So there's a couple of ways that we can do it. So let me actually clear all of this. We've figured out all of this stuff. So let me clear all of that out. And let's actually draw a box and whiskers plot. So I'll put another, actually let me do two here. That's one. And then let me put another one down there. And this is another. Now if we were to just draw a classic box and whiskers plot here, we would say, all right, our median's at 14, and actually I'll do it both ways. Our median's at 14, median's at 14, Q1's at 13, Q1's at 13, Q1's at 13, Q3 is at 18, Q3 is at 18, Q3 is 18, so that's the box part. And let me draw that as an actual, let me actually draw that as a box. So my best attempt, there you go, that's the box. And this is also a box. So far I'm doing the exact same thing. Now if we don't want to consider outliers, we would say, well, what's the entire range here? Well, we have things that go from 1 all the way to 19. So one way to do it is say, hey, we start at 1. And so our entire range, we go, actually let me draw it a little bit better than that. We're going all the way from 1 to 19. Now in this one, we're including everything. We're including even these two outliers. But if we don't want to include those outliers, we want to make it clear that they're outliers, well, let's not include them. And what we can do instead is say, all right, including our non-outliers, we would start at 6, because 6 we're saying is in our data set, but it is not an outlier. Let me make this look better. So we are going to start at 6 and go all the way to 19. And then to say that we have these outliers, we would put this, we have outliers over there. So once again, this is a box and whiskers plot of the same data set without outliers. And this is one where we make it clear where the outliers actually are.